Hey there, fellow cosmic explorers, and welcome back to the orbit of understanding. I'm your guide through the infinite universe of knowledge, and today we're not just taking a giant leap. We're doing a quantum teleport into a realm that's stretching the very fabric of what's possible, quantum computing. Now, before your brain starts feeling like it's in a superposition of utterly confused and intrigued beyond measure, let's demystify this incredible technology. Trust me, by the end of this journey, you'll be dropping quantum knowledge like a pro at your next intergalactic dinner party. Or, at the very least, you'll understand why your current laptop isn't quite cutting it for instantly teleporting a fully baked pizza from Italy to your couch. Though one can dream. So, what's the fundamental difference? Well, your everyday computer, the one you're likely watching this on, is built on the foundation of bits. Think of a bit as the simplest possible light switch. It's either definitively on, representing a 1, or definitively off, representing a 0. It's digital, it's decisive, and it's how we've built the entire digital world we interact with daily, from emails to cat videos. But quantum computers? Oh no, they're not content with such binary limitations. They operate using qubits. And a qubit isn't just a simple light switch. Imagine a light switch that, thanks to a mind-bending quantum phenomenon called superposition, can be on, off, or both at the same time. It exists in all possible states simultaneously until it's measured. It's like Schrödinger's cat, but for information. For those unfamiliar, Schrödinger's cat is a thought experiment where a cat in a sealed box is simultaneously dead and alive until you open the box and observe it. In the same way, a qubit holds multiple possibilities until we look at it. Think about it this way. If you're trying to find a specific book in a massive, unorganized library, a classical computer would meticulously check each book, one by one, until it found the right one. It's a sequential, step-by-step process. Slow, but reliable. A quantum computer, however, thanks to superposition, could theoretically check all the books in the library simultaneously. It's like having a million quantum librarians working at the exact same instant, all of whom are also part-time ninjas, capable of being in multiple places at once. This parallel processing power is what gives quantum computers their truly mind-boggling advantage for certain types of problems. But wait, there's even more quantum weirdness. Qubits also exhibit another truly bizarre phenomenon called entanglement. This is where two or more qubits become so intimately linked, so deeply connected, that no matter how far apart they are in the universe, if you measure the state of one, you instantly know the state of the others. There's no time delay, no signal traveling. It's instantaneous. It's like having a pair of quantum socks. You look at one, and you immediately know if the other one is clean, has a suspicious stain, or perhaps even materialized a tiny top hat, without even looking at the second sock. Spooky, right? Even Albert Einstein famously called this spooky action at a distance. And frankly, if it spooked Einstein, you know it's seriously cool and defies our everyday intuition. This entanglement allows qubits to share information and cooperate in ways that are simply impossible for classical bits. It's not just about speed, it's about a fundamentally different way of processing information, where the relationships between pieces of data are leveraged in a powerful new way. And then there's quantum interference. This is where probabilities amplify or cancel each other out. Think of it like waves in water. When two waves meet, they can either combine to make a bigger wave, constructive interference, or cancel each other out, making the water flat, destructive interference. Qubits use this principle to find the right answer. The correct paths to a solution amplify each other, while the incorrect paths cancel out, making the desired answer more likely to be found. It's like quantum computers are literally shouting out the right answer and whispering away the wrong ones. So why are scientists, tech giants, and governments pouring billions upon billions into this incredibly complex, cryogenically frozen technology? Because quantum computing isn't just a neat parlor trick for physicists. It has the potential to fundamentally revolutionize countless industries and solve some of the world's most intractable problems. Problems that are currently beyond the reach of even our most powerful supercomputers. Let's dive into some of the most exciting potential applications. 1. Drug discovery and material science. Imagine designing new medicines that precisely target diseases, leading to breakthroughs in treating everything from cancer and Alzheimer's to new pandemics. Our current computers struggle to accurately simulate the complex interactions of molecules. Quantum computers, however, can model these interactions at the atomic and subatomic level with unprecedented precision. This means Faster drug development, identifying promising drug candidates much more quickly. Personalized medicine, creating treatments tailored to an individual's unique genetic makeup. Novel materials, designing new supermaterials with incredible properties. Think self-healing metals, ultra-efficient batteries, superconductors at room temperature, or even materials for super-fast space travel. The possibilities here are truly boundless. 2. Artificial intelligence. Artificial intelligence, or AI, is already transforming our world. But quantum computing could supercharge AI to an unimaginable degree. Quantum computers can process vast amounts of data and explore complex relationships that are currently computationally impossible for classical AI. This could lead to smarter AI algorithms, improving pattern recognition, machine learning, and deep learning, leading to more human-like intelligence. Optimized decision-making, enabling AI to make vastly more complex and nuanced decisions in areas like logistics, resource allocation, and even climate modeling. True breakthroughs, moving beyond current AI limitations to unlock entirely new forms of machine intelligence. We're talking truly intelligent AI, not just your phone's sarcastic assistant who still can't quite understand your accent. 3rd, financial modeling and optimization. The financial world is incredibly complex, with countless variables influencing markets. Quantum computers could revolutionize financial modeling, allowing for more accurate risk assessment, better understanding and mitigating financial risks, optimized portfolios, maximizing returns and minimizing losses with unprecedented precision, fraud detection, identifying complex patterns of fraudulent activity that are currently hidden, algorithmic trading, developing vastly more sophisticated trading strategies, supply chain optimization, ensuring goods move efficiently around the globe, saving businesses billions, and ensuring your favorite quantum teleported pizza arrives on time. And lastly, cybersecurity. This is a truly fascinating and critical area. The very power that makes quantum computers so revolutionary also poses a significant threat to our current digital security. Many of our existing encryption methods, like RSA, rely on the mathematical difficulty of factoring large numbers. A quantum algorithm, Shor's algorithm, could efficiently break these encryptions, potentially rendering our current internet security vulnerable.
Sounds scary, right?
But here's the good news. Quantum computing also offers the promise of creating truly unhackable quantum encryption. Technologies like quantum key distribution, QKD, use the laws of physics, specifically entanglement and superposition, to create encryption keys that are impossible to eavesdrop on without detection. So while we're undoubtedly in a quantum arms race, the goal is to develop post-quantum cryptography that is resistant to quantum attacks, ensuring our digital lives remain secure. It's like discovering a super-strong crowbar, but then also inventing an unbreakable lock made from the same super-strong material. Hopefully, the good guys get the new locks first. Now, before you start clearing space on your desk for your brand new quantum laptop, it's important to understand that we are still in the very early stages of quantum computing. Building and maintaining these machines is incredibly challenging. Remember our qubits? They're fragile. They're like tiny temperamental toddlers who get upset if you so much as look at them wrong. They need to be isolated from any environmental interference, heat, vibrations, electromagnetic fields, that could cause them to lose their delicate quantum properties, a phenomenon called decoherence. To combat this, many quantum computers need to be kept at temperatures colder than outer space, just a few millikelvin above absolute zero. That's colder than the vacuum of space. We're talking about incredibly sophisticated engineering. But despite these immense engineering hurdles, progress is happening at an astonishing rate. Companies like IBM, Google, Microsoft, and many pioneering startups are making incredible strides. We're seeing quantum computers with increasing numbers of stable, interconnected qubits, known as qubit count. We've gone from a handful of qubits to machines with dozens, and soon hundreds. The race is on to achieve fault-tolerant quantum computing, where errors that naturally occur in fragile qubits can be detected and corrected. This is the holy grail that will unlock the true power of quantum computers for practical, real-world problems. The journey is long, but the potential rewards are immense. The future of quantum computing is not just about faster calculations. It's about solving problems that are currently impossible. It's about opening up entirely new frontiers of scientific discovery, technological innovation, and perhaps a deeper understanding of the universe itself. It's about truly understanding the universe, one superposed, entangled, temperamental qubit at a time. Alright, fellow cosmic voyagers, now it's your turn to engage. What excites you most about the potential of quantum computing? Do you think it will change the world as dramatically as the internet did? And if you had access to a fully functional quantum computer, what's one truly impossible problem you'd want it to solve? Let your imagination run wild. Share your thoughts, your wildest theories, and your most profound quantum questions in the comments below. We love hearing your insights and expanding the orbit of understanding together. If you enjoyed this mind-bending journey into the quantum realm, make sure to hit that like button. Share this video with anyone who needs a dose of future tech, and of course, subscribe to Orbit of Understanding for more incredible explorations into science, technology, and the universe beyond. Until next time, keep your curiosity in superposition, your minds open to the infinite possibilities, and never stop exploring the unknown.